Hello, so welcome to the channel once again. So in this video, I'm going to be showing you how to do statistical analysis, univariate analysis for our joint prediction data. And we shall be using statistical tools like your odd ratio, your chi-square test, your Cohen's d test, your McVitie test for our statistical analysis. So by the end of this video, you should be able to do statistical analysis on churn prediction data to find out key elements of churn. So in the previous video, I showed you how to do data pre-processing and visualization. We imported the necessary libraries that we needed, imported the data set, cleaned it up. We have 5,630 rows, 20 columns. We were able to drop some of the irrelevant columns, and we were left with 17 columns. And we dealt with our null values. I showed you how to do that in-depthly. And we went ahead to divide our data sets into categorical columns and numeric columns. And then we dealt with the null values. And as you can see here, there are no null values anymore. Then we went ahead to rename some of our columns. And here we are on statistical analysis, Univariate. Okay, so first of all, I would like to explain some of the tools that we are going to use so that you understand why we are using them and how to interpret the figures they will be presenting to us. Okay, the first is the odd ratio. Now, let's start with the odd ratio. So what is an odd ratio? Simply put, it is a measure of association between a predictor variable and a binary outcome variable. In this case, our churn output, which is a binary variable 0 and 1. So in our case, we are looking at churn. So our outcome variable is whether a customer churns or not. The odd ratio rather tells us how much more or less likely a customer is to churn based on a particular predictor variable. For example, let's say we are looking at the relationship between discount and churn. If the odd ratio is, let's say, 0.8, that means that for every unit increase in discount, the odds of churn decreases by 20%. Yes, because it is not up to 1. We're having 0.8 there. So it decreases by 20%. So that tells you the strength, the magnitude of the magnitude the input feature discount has on churn. All right. Now, on the other hand, if the odd ratio is, say, 1.2, that means that for every unit increase in discount, the odds of churn increases by 20%. Do you understand? So how do we interpret the results of an odd ratio? Well, if the odd ratio is greater than 1, it means that the predictor variable increases the likelihood of churn. And if it is less than 1, it means that the predictor variable decreases the likelihood of churn. And if it is equal to 1, it means that there is no association between the predictor variable and the churn. The next is our chi-square test. So this test is used to determine whether there is a significant association between a categorical predictor variable and a binary outcome variable. The chi-square test works by comparing the observed frequencies of each category to the expected frequency under the null hypothesis of no association. Okay, so if the observed frequency are significantly different from the expected frequency, we reject the null hypothesis and conclude that there is a significant association between the variables. So this will bring us to create what we call our contingency table, where we will have our observed frequency and our expected frequency. So we'll bring in what we call a contingency table. So don't be afraid, it's all there in the Python software. Okay. Now, how do we interpret the results of a chi-square test? Well, the key thing to look out is the p-value. So if the p-value is less than a certain significant level, in our case, we'll be using 0.05 significant level, we will reject the null hypothesis and conclude that there is a significant association between the variables. If the p-value is greater than the significance level, we shall fail to reject the null hypothesis and conclude that there is no significant association. The third one is coherence D test. Now, how about the coherence D test? This is a measure of effect size that tells us the magnitude of the difference between two groups. In our case, we are looking at the difference between customers who churn and customers who don't churn. So coherence D is calculated as the difference between the means of the two groups divided by the standard deviation. Also, about the coherence D, to further help your understanding of the tool, it is a descriptive statistics that quantifies the magnitude of the difference between two groups. Like I said before, it doesn't imply causation, please take note of that, but rather it gives us the understanding of the strength of the association. But rather it helps us understand the strength of the association between the predictor variable and the outcome variable. So the effect size represents the magnitude of the difference in the predictor variable between customers who churn and those who don't. Now, suppose you find a coherence D of 0.8 for the predictor variable price hike between churners and non-churners. What does this mean? This means that the average price hike experienced by churners is 0.8 standard deviation higher than that experienced by non-churners. This doesn't necessarily mean that the price hike causes churn, but rather that there's a strong association between the two variables. So I hope you understand that. So how do we interpret the result of coherence D test? Coherence D can be interpreted as follows. A small effect size is around 0.1 to 0.3. A medium effect size is around 0.5 to 0.7. And then a large effect size, that is very strong association, is around 0.8 or more. The last but not the least, the Mann-Whitney test. This test is used to compare the distribution of two groups. It is a non-parametric test, which means that it doesn't assume a normal distribution of data. The Mann-Whitney test works by ranking the data and comparing the ranks between the two groups. If the ranks are significantly different between the two groups, we reject the null hypothesis and conclude that there's a significant difference between the distributions. So how do we interpret the result of a Mann-Whitney test? Well, again, we look at the p-value. If the p-value is less than the significance level, we reject the null hypothesis and conclude that there's a significant difference between the distribution. And if the p-value is greater than the significance level, we fail to reject the null hypothesis and conclude that there is no significant difference. So why are we using all of these tools? So, from our data set, we have categorical variables and numeric variables. So not all of these tools can work on categorical variables and vice versa. So some will work on numeric variable, some will work based on numeric variables, and others will work based on categorical variables. That's why we came up with 4. So we shall be using the odd ratio and the chi-square test for our categorical variables, and we shall be using the coherence D and the Mann-Whitney test for our numeric variable. Okay, so let's get to our Jupyter notebook and let's begin. First thing we are going to do is that we are going to import more libraries here that will enable us to do our statistical analysis. So I'm going to zoom in, and we are going to import more things. So from scipy.stats, let's import chi-squared contingency. Let's also import our man with name. Test. The next thing is your from SK from sklearn dot linear model imports logistic regression. You might be wondering, so why are we importing logistic regression? Are we going to do model building? No, we are not going to do that. In logistic regression, see the coefficient represent the change in the log odds of the outcome variable, say the Churn variable in this case, for a unit change in the predictor variable, while holding all other variables constant. You understand? So to calculate the odd ratio, we exponentiate the coefficient, which gives us the ratio of the odds. Yeah, you get. So odds ratio equals to exponent of the coefficients that we are going to get. So that is, we are going to use it to calculate our odd ratio. You understand? This gives us a more interpretable measure of the relationship between the predictor variables and the outcome variable. You understand? So we are not going to do model building, but we are going to extract the coefficient of the coefficients from the logistic regression model that we're going to build, and from there we exponentiate it to get our odd ratio. Do you understand? Okay, so let's progress. Okay, so I think we are good. That works. That works. So now, let's start with our categorical variables. So we are going to use a for loop because we can't afford to do them one column after the other. We have over 17 columns. We don't have all the time in the world to start doing one after the other. So we are going to use our for loop to iterate through each columns and give us the result. Remember, before now we have separated our columns into numeric and categorical columns. As you can see here, you have a numeric column and you have here a categorical column. Okay, so let's start with the categorical column. So let's use our for loops for all the columns in our now. The first thing we're going to do is that let's create our contingency table. So let's create our contingency table. So and how do we do that? We say contingency table equals ed.crosstab
Then we want to call that. Look that.
df. Do that for all the columns. So that means you are going to create two tables. One column will be for our churn and one column will be for each individual feature columns, feature variables. And then the next thing we are going to say print what? Supre. contingency table
E.
for the columns. Again, print contingency table.
No. On the date won't pa. That's easy.
Leave a space after one column so that our result will be more interpretable. So we do this and we let it be. Let's hit create. Okay, so can you see contingency table for preferred order category? Contingency table for my status. All right, that is that. But this is not the final output that we want. We want to use this to calculate our chi-square. So let's progress. So let's do our chi-square test now. Chi-square test. And how do we do that? P value, degree of freedom, and our expected all equal to chi-square contingency. Then we bring in our contingency table that we created at this point. So let me just copy that to avoid any sort of errors. Okay, and then we are going to say print again. We need another space, so click and we need another space, and then before we click shift enter, we need to visualize this. Remember last video I told you we'll be doing EDA, so we'll do it at once here. Just visualize the data so that we can make more meaning out of the figures that are statistical, chi-square test, and other statistical tools that we are going to use. So I'll make more meaning from our chi-square test. So let's use the bar charts. Okay, so plc.figure, set our fixed size. So we want it to be 4, not so big. And then set our contingency. That plot the kind we want it to be a bar chart. And then our chart title will show the relationship between each column that will go in there and no, ouch, and churn. All right, and then for our X label, we'll let it be the column. That is a feature variable that will go in there. Then for our Y label, say count. Oh, what else? PLT. But sure. All right. I think we should print our chi-square value now. Although I intend to bring it at the back for a better organization, but let me just print it first. So let's print our chi-square. So chi-squared. Chi-square test for each individual column. And then p-value equals p-value again. And you are good. Let's hit our control key now. Oops. We have an error. Where is that coming from? Okay, we needed to put this. All right, and okay, here we go. Preferred login device. This label should be called no, we shouldn't be having 0 and 1 here. We should be having yeah. Okay, so here we go. You can see our chi-square table. You can see our chi-square result p-value 0.00001 for preferred login device. You can see that many people prefer using phone to okay, I think okay. So you see that many people prefer using phone to their computer device, and as such the churn rate increases is higher for mobile phone than computer. And we look at the relationship between payment mode and churn. So we see more people prefer using the debit card, followed by the credit card and the e-wallet. As you can see now, the chi-square test for this is 1.4 exponential negative 10. All right, and for gender, you can see that as well, that the male folks are more likely to churn than the female, and we have more male customers than the female. And preferred other categories, as you can see. So let's finish up. I'm going to zoom in now. So we have established that there is significant relationship between some input feature and our churn from the chi-square test, but see, this one is less than 0.05. So that means marital status is statistically significant. However, we need to find out the direction of significance. is it that marital status increases churn or it reduces churn? In what direction is this significant association? So we are going to bring in the odd ratio now. So let's go over and bring in the odd ratio. So let's investigate the direction and strengths of the relationship. So the first thing we are going to do, I told you we are going to use odd ratio, and to do that, we are going to use the coefficient from our logistic regression model. Okay, so the first thing we are going to do is we are going to use our label encoder. Did I import label encoder? Okay, yes, I did. So we are going to use our label encoder and change those categorical variables to numeric so that our model can work with them. So label encoder. So df call equals to label encoder dot fit transform. What are we transforming? We are transforming our categorical column, each of them, every one of them. All right, and that is that. That works. That works. So the next step is to split our data into training and test sets. Split data set into training and test sets. And we are going to use our so let's just do that. You say let our x be df call. We need another square bracket there so that first, and then our y will be df Churn column, and we are good. So let's train our model. And how do we do that? Say model equals to logistic regression. We initialize that, and then model dot fit. Then we bring in our training set. Okay, so we don't need test set for now because we are just interested in getting the coefficient, the regression coefficient. Okay, yes, and then now we can now apply our odd ratio to get what I want. So apply the odd ratio to apply the odd ratio function to the coefficients of the regression equation. That is very simple. So we say odd ratio odd ratio equals NP numpy dot exponent. Remember I talked about exponenting the coefficients of what order coefficient and that is that. As simple as that. Next, we are going to print our results. So next, I'll print odd ratio for this column. Well, I would like to bring in our print function for the chi-square test so that it stays at the same place with the odd ratio. So let me just bring this one here. Just before our let me bring that one there. All right. Okay, so we are good. The next thing I'm going to do is I'm going to say print. I need a demarcator. Let me use this. I need a demarcator there. So I need a line, print a line. Let's say 75. And then I need another space. Good. Now let's control enter. Oof, model coef is not defined. Model coef. Oh, cool. Oh, shit. Okay, there was an error there. Remove this underscore and bring in dots. So I'm going to zoom out, and as you can see, I think it's more structured now. This is a contingency table. Let's start with the very first. So this is our contingency table. We have the visual for the relationship between preferred login device and churn. This is the count of a chi-square test for preferred login device. P-value is 0.00014, which is statistically significant. And then we have the odd ratio to be 0.749. That is impressive. That is impressive. In contingency table for preferred payment method, this is it. And the visual for that preferred payment method, this is it. Is odd ratio. Gender, this is the odd ratio. P-value 0.03, meaning it is statistically significant. And this means, so the odd ratio here is 1.17. This means that for every unit of increase here in the gender, the odds of churning increases by 17%. This one means that 1.006 for every unit increase in preferred payment mode, the odds of churning increases by 0.6%. You see, we have just gotten the strength now. Now, that will mean that gender is more strongly associated with churn than preferred payment method. Can you see that now? Let's look at another one, preferred order category. First of all, it is statistically significant. 2.77 is minus 60. And then the odd ratio is 1.26. That means for every unit increase in preferred order category, the odd of people churning, customers churning, is 26%. Okay? Increases by 26%. The odd increases by 26%. So you see, this means that preferred order category is stronger than gender, and gender is stronger than preferred perimeter. So you see that our odd ratio have given us direction and the strength. So if you were to pick the key element of churn among these three features, preferred order category will come first because the odd is 26% increase in churners, and this one is 17. The gender is 17% increase in churns, and this one is 0.6% increase. That is the odd of churners increased by 0.6%. So we can see that we now have a direction. And then there is this other one I will need to show you. Preferred login device. It is statistically significant because the p-value is 0.000014. And then the odd ratio says it is 0.7. This means that for every unit increase in the preferred login device, the odd of people churning reduces, not increases this time, reduces by 26%. Can you see that? 26%. 26%. So that would mean you have to work on a preferred login device to make it more easier for customers to use. Okay, that's just a brief recommendation, but we are going to do that later after we are done with a statistical analysis for numerical variables. Okay, so let's quickly go to numerical variables. So for our numerical variables, we are going to say use a for loop again. Let me zoom in. So for call, in num call, like numerical calling this time around. First of all, we are going to visualize. So let's visualize. Let's visualize. I'm using our bar chart. Oops, what did I do? Let's visualize using our bar chart. Yes. So KLT dot figure, set figure size 4x2. Sorry, histogram rather. We are going to use our histogram. Histogram. So PLT dot hist df dot log churn, when churn is equal to 0, then alpha, set our alpha to be 0.5, and our label to be and non-churn. Just going to copy this again, paste df dot log, change this one to 1 this time around, alpha is still 0.5, and then churn. Okay, yeah. KLT dot title. Our title will be relationship between our column and churn. And then we'll have the journey will be yes. We upload it at X level. X level will be each individual input variable. Y label will be count, and then we have show print, but we need space. All right, need a space there. So you can see relationship between tenor and churn. So tenor. So what does this mean? This means that customers with who spends less time are more likely to churn. Then what will be the recommendation? Focus on more retention strategies. Can you see? This is the time spent maybe in the company, maybe a number of times they made the purchase. So we find out that those customers that made maybe one or two purchases are more likely to churn than those who have made many purchases, or than those who've been buying from the company for a long period of time. So you can see that the churn increases with those recent ones, those recent customers, those who are new to the business, to the company or the product or whatever. So the recommendation should be increase more retention strategies, as you can see. Okay. Relationship between city tile and customers. So those living between 1 to 2 kilometers and 3 kilometers away are more likely to churn. You can see that then distance between warehouse to homes, we may not have customers coming all the way from 60 kilometers away from where the warehouse is. So we see that we have between, let's say, 5 kilometers to 35 or 38 thereabout. So next is relationship between hours spent on app and churn. As you can see, those who spend up to 3 hours are more likely to churn. You spend up to 4 hours and 2 hours and thereabouts. And we have more people spending. So this tells us that most people spend on an average 3 hours on the app. Okay. And the greater number of people who churn spend up to 3 hours on the app. So we don't know yet, because we are yet to do this statistical analysis to find out the relationship between these input variables and churn. But from the visuals, we can get some insights. Okay, so let's proceed. Let's proceed. So next we are going to use our Mann-Whitney U-test to find out which input variable is significant or is associated to our churn variable. So let's do that right now. Nope. Don't know. Press rubbish. Whitney U-test. So low starts p-value equals to Mann-Whitney U bracket open df lock Churn equals 1
The students this. No, use this. Crap, mom. Wanted to call you because of a knowledge of pregnancy.
So next brings Mann-Whitney U tests for each column with each column A p-value equals p-value so Mann-Whitney test for tenor is 1.3, so we can say that, like I said, tenor is statistically important. Can you see that now? Okay, so city tag is equally important. Distance to warehouse important. Hours spent on app not important, not significantly important. Satisfaction score, of course, should be important. Complain, of course, should be important. Order amount hike from last year, not important, meaning not statistically significant. We don't need it. Coupon use, we don't need it. Order counts, statistically important. Day since last order, statistically important. Cashback amount, of course, that should be important. Good. Now let's find out. Let's quantify their importance and know which one is more likely associated with churn than the other. Let's find out using our coherence D test. So we say, let's quantify the effect of the relationship using coherence D. Let's quantify the effect of relationship using coherence D. So channel values equals to df dot of df. churn equals to 1. Just going to copy this, change this one to 0, and then this one to non-churn values. Then I'm going to say t stats p value equals to t test churn value non-churn values and t equals t stats multiplied by np, that's square root 1 all over number of churn values plus 1 all over number of non-churn values. Next one is print. Go hence the for each column when we need a line for easy visualization. So not this, but this, and do that for give us 75 of that. Next, we need space. So just give us space. Just give us space. Enter. So for tenor, Matt Whitney U test significantly important. Coherent T. Okay. I missed something. So we needed to do that for each column. Each column, please. We needed to do that for each column. Here we go. So coherence D for tenor is negative 0.95. And remember the interpretation for coherence D. A small size effect is around 0.1 to 0.3. Medium effect size is around 0.5 to 0.7. And a large effect size is around 0.8. So here we have our Madwini test for tenor is this, which tells us that it is statistically significant. And then coherence D for tenor is negative 0.95. What does it mean? It means that customers who churned tend to have lower tenor than the lower tenor compared to customers who do not churn. Now, to see what we have just said, look at the graph. What do you see? See? Churn. And then we have this one here. See? Lower tenor. We have more churners with lower tenor. So that is what our OSD is telling us, that customers who churn tend to have lower tenor than those who do not churn. And what is the strength? Very big, very big, 95. Can you see that? So this tells us that tenure has a very large effect size. So this is very, very important. Tenure is very, very important and is a key churn element here. Next, relationship between city tile 0.22. 0.22. What does it mean? It means that those who churn tend to have greater distance, but the effect is not so much, only 0.22. Next is warehouse to home. Those with greater distances are more likely to churn. Can you see? Because it's positive. The coincidence is positive. App, not so important. Satisfaction score. Let's see what this means. Well, satisfaction score, this interpretation looks a little bit tricky because it is counterintuitive. From the visual, we see that those customers with higher satisfaction score are more likely to churn, as you can see here. And then our cohend test is confirming that as well, that those who churners have more satisfaction score because it is positive, but the magnitude of that is weak because it is 0.28, very weak. However, that sounds counterintuitive, like I've said before. What could be the possible reason that those with higher satisfaction score are likely to churn? Well, we will need more data to find out that. It is an interesting insight that we have just discovered. Well, our possible reasons could be complacency. Highly satisfied customers might become complacent and less engaged, leading to a higher likelihood of churn, or there could be other reasons. So we will still need to investigate that if we have more data. Then we have relationship between complaint and churn. Okay, we see that our Whitney test tells us that complaint is statistically significant, greatly significant. And then we have a coherent test of 0.69 telling us that this has a very great impact on churners. All right, so the greater the complaint, the more likely customers are to churn. Okay, and then relationship between other amounts is not statistically important, so we leave it. Coupon use, not statistically important, we leave it. And other counts, statistically important, but the effect size is about minus 0.06, and the minus tells us that the greater the other count, the less likely we are going to have churners, which is good, and it makes sense. The more the people buy, the more the less you are likely to have churners, negative signs. So this makes sense. Then since last day order, p-values statistically important, effect size medium, effect size of this order count on churn negligible, very weak. Cashback amounts statistically important. Yeah, see, this tells us that the greater, because it is negative and it has a medium effect size, tells us that the greater cashback amount we have, the less likely we are going to have churners. This is good. So what recommendation is there? What recommendation could we possibly come up with? That is cashback amount. A company should work on increasing cashback amount to customers as it reduces churn. Great. So now we have finished the statistical analysis. What are our recommendations and what have we discovered? What are the key elements of churn? So I just came here to ChatGPT to help extract, given the statistical results. I know I can't do that manually. There are over 17 columns. I can't start picking them one after the other. So I brought in AI, ChatGPT, to pick those ones, the top key elements of churn based on the statistical result we've generated, and we've been able to see here the top registers tenor. You see tenor, like we saw there, extremely significant. Okay, meaning that those with shorter tenor are more likely to churn. We have preferred other category, as you can see. We have complaints. Can you see? So these are the key elements of churn. Marital status. These are the key elements of churn. And I need to show you something on that marital status. I think it was on categorical marital status. No, marital status. Marital status. Okay. Let me zoom out. You see, so from here we see that the single people are more likely to churn. Can you see that? Single people are more likely to churn. Look at their odd ratio, 1.8. Can you see that? Meaning a unit increase in marital status. These people have 80% odd of churning. Can you see? And which set of people are responsible for that? Is it the divorce? No, their churn rate is low. Married, a bit high, and single people. So we are going to need more data to find out the reason why married and single people are not satisfied with the product they leave after purchasing. That is the churn. We need more data to find out. So our target will be the married people and the single people, as you can see from the visuals. So cashback amount, and then the moderate predictors are satisfaction score, city type warehouse. So with this, I believe you have seen how we can do our statistical analysis to identify key elements of churn. Now tell me what you think in the comment section. If there's an area you need me to expand more on, explore more on, let me know in the comment section. Thank you for watching. Don't forget to hit that subscribe button, like, and share this video to as many people as you can. Thank you. See you in the next video.